This is a problem from your lab assignment, section 7.1. This is problem number 1. They want us to evaluate the integral of 2x times sine 9x dx. And in this case, we have a product of two things, so we're going to use integration by parts. The formula says that we're integrating u dv, and that's going to turn out to be uv minus v du. And so the key is to try to figure out which one is u and which one is dv. The general rule of thumb is that if you have a polynomial and a trig or an exponential function, you're going to let u equal to the polynomial because you're going to take the derivative of u, and the derivative of polynomial would be another polynomial with one less power in the degree. And then the v would be integrated. The dv would be integrated to get the v, and then usually exponentials and trig functions will remain as exponentials and trig. So in this particular problem, we're going to let u equal to 2x. So that means the rest of this, including the dx, is going to be our dv. So our dv is going to be cosine of 9x dx. So now we'll take u and we'll take the derivative of that because we'll need that. The derivative of u is going to be the derivative of 2x dx. And so that's just going to be 2 times dx. Now we have dv, and then we're going to eventually want v in our formula. So we need to undo this differential, which means we need to integrate the cosine. So there's going to be a u substitution here. We're going to let u equal to 9x, and then du is going to be 9 dx, and that's going to give us a 1/9 as an extra factor. And then the integral of cosine, if you remember, is going to be positive sine. So this is going to be a sine, and then you have the same angle, 9x. So if that went a little fast, I would encourage you to come back here and do the u substitution where u is equal to 9x, and then get that v. Alright, so according to this formula, we have u is 2x, and v is 1/9 sine 9x. du is going to be 2, and dv is going to be cosine 9x dx. So according to this formula, this is going to equal to uv. So u is equal to 2, or I'm sorry, u is equal to 2x. So this is going to be 2x. Well, it looks like the x is already there, so let's take this x out. And then we have a 1/9 sine 9x, so the 1/9 is down here, sine 9x. So this completes the u times v portion of the integration by parts. Now we have to say v du. So v is equal to 1/9, so there's a 9 in here, sine 9x, so this is sine here, and then a 9x, times u or du is going to be 2 times dx. So the 2 is here, and then the dx is here. So let's submit that. So we got our constants all straightened out. Now we got to do another integral here. That's the integral of 9x. The 2/9 will just keep outside. The integral of 9x is just going to be again another u substitution. This is going to be 9 1/9 dt, and then we do this integral. We're going to get the 1/9 as an extra constant. The integral of sine this time is negative cosine 9x, so don't forget the negative from the cosine. And then they say ignore the c there because we're going to put the c at the very end. So let's combine everything. So the integral is going to be 2x sine 9x over 9. So let's put 2x here, and then we have times, and then a 1/9 sine 9x minus the integral that we just got. And so don't forget that there's a 2/9 there. And then there's also a negative that came out, so we can either change this into a positive, or let's just make this clear here. We have a negative 1/9 times cosine 9x. Okay, so that's u times v minus the integral of v. So the integral of v is this thing. Du is 2, and then there was dx in there, but we took the integral already. So we'll just put a plus c, and that should be it. Now, of course, there's simplifying that can happen. We have a 2/9 x, which is what they have here. We can do the negative, and the negative is a positive. And then the 2 divided by 9, and then an extra 9 in the denominator, that's 2/81, and then plus c. Okay, I hope that helps.